This AI can fill the missing pixels behind a removed moving object and reconstruct the whole video with way more accuracy and less blurriness than current state-of-the-art approaches. Let's see what this AI is really capable of and how the researchers achieved that. This is What's AI, and I share artificial intelligence news every week. If you are new to the channel and want to stay up to date, please consider subscribing to not miss any further news. Researchers at Sun Yat-sen University in China recently published a paper accepted in the ECCV 2020 convention, covering a new technique for video and painting, which they called Learning Joint Spatial Temporal Transformations. The ECCV, or European Conference on Computer Vision, is the top European conference in the image analysis area. In image analysis, video and painting is the process of completing missing regions in a video frame. It is a challenging task in machine learning. The state-of-the-art current approaches use attention models in order to find the missing pixels of a frame by searching content from reference frames. Then, it reconstructs the whole video frame by frame. Using this attention technique, which I covered in a previous video, has some issue. As they explain in their paper, it can suffer from inconsistent attention results along spatial and temporal dimensions, which often causes blurriness and artifacts in videos, as you can see in this image. They propose to use a method called Spatial Temporal Transformer Network, or STTN, instead of working with attention. In short, they use self-attention to simultaneously fill missing regions in all input frames where an object of the foreground has been removed. I also explained the difference between attention and self-attention in the video previously mentioned. This video is linked in the description box below if you are interested. Then, they use an optimized version of this STTN, which takes both neighboring and distant frames as inputs and simultaneously fills missing regions in all input frames using adversarial training. This network is composed of three main components. First, there's a frame-level encoder, which, as its name says, encodes all the frames of the video into three 1x1 dimensional values detailed in the next step. This encoder is just several two-dimensional convolution layers stacked together, which aims at encoding deep features from low-level pixels for each frame. Then, these outputs are sent to a multi-layer, multi-headed spatial temporal transformers, which are the ones designed to fill the holes in all input frames as mentioned earlier. But in details, a single transformer matches the queries Q and the keys K across a wide variety of scales, using the multiple heads, making it possible to detect the values V of relevant regions covered by the holes. This wide variety of scales used in these multi-head transformer allows the network to complete stationary background using large size patches, as well as capturing deep correspondences in any locations of videos for moving foreground objects from the smaller patches. The said patches are all calculated by matching the queries and keys among spatial patches that are extracted from all the frames in the first step. This is the key part of the network, searching for coherent contents from all the input frames. Everything explained in this crucial step could be summarized by this phrase: learning joint spatial temporal transformations for all missing regions in the deep encoding space. Moreover, these transformers' heads all run in parallel, making this network extremely fast. The final step is to send the multi-layer features found by the transformers into a frame-level decoder in order to reconstruct the frames of the video from these features. Now that we have a better idea of how it works, let's look at some amazing examples made using this technique. As discussed, it is able to remove an object from a video and fill the regions under it using the background and temporal information. Just look at how much the blurriness is way less apparent in their method. They were also able to fill stationary holes fixed through the whole video using their method with the same information. Of course, this was just a simple overview of this new paper. I strongly recommend to read the paper, linked in the description for more information. Please leave a like if you went this far in the video. And since there are over 90% of you guys watching that are not subscribed yet, consider subscribing to the channel to not miss any further news clearly explained. If you want to support the channel, I now have a Patreon linked in the description where you can do that. Thank you for watching.